Hi, Rachel here from Studies Made Simple. I'm just going to be going over very quickly today just some of the differences between galvanic cells and electrolytic cells. So I'm just going to call galvanic cells G cells and then electrolytic cells E cells. So we're just going to highlight some of the main differences here. So we'll start with the G cells. And we're going to see that we're going to compare them to the E cells over here. So the first thing is G cells are always going to have a positive E, so a positive EMF. So we're going to write that in there. And that means that when we have a positive EMF, so positive voltage, it's going to be a negative delta G, which means that this reaction is spontaneous. So these reactions are happening spontaneously, and we'll go more in detail into what that means later. So we're going to have a negative anode. And then we're going to have a positive cathode with these G cells. Now, the E cells are essentially going to be the opposite of this. We're going to have a negative E, which means that we're going to have a positive delta G. And then, yes, you guessed it, the anode is actually going to be positive in the E cells, and our cathode is going to be negative. So I like to just learn one of these. I like to just focus on the G cells and just know that electrolytic cells are going to be the opposite. Electrolytic cells are going to require battery, and the anode is going to have the positive charge because it's going to be connected to the positive terminal of the battery. So a couple of things that are applicable for both cells is that oxidation is always going to occur at the anode. So we're going to have oxidation, and like I said, that's always going to occur at the anode, regardless of whether it is a G cell or an electrolytic cell. And then reduction is that's going to occur at the cathode. So an easy way of remembering this, and you might have come across this before, is I'll just highlight in red over here. You can remember, actually, that's the wrong way around. So you can remember it an ox and then red cat. So again, you see here we have AN for anode and OX for oxidation, and then we have red cat over here. So regardless of which type of cells these are, we're always going to have oxidation occurring at the anode and reduction at the cathode. If your EMF is positive, then that's going to have a negative delta G. So that's just a good thing to remember. The movement of electrons is always going to be from anode to cathode. So when we have electrons, they're always going to be going from the anode to the cathode, and the current is going to be the opposite of that. So that's a couple of little things to note in the difference between the G cells and the E cells. Thanks so much for watching.